The objective behind this experiment is to design one that determines the spring constant of a spring based on the measurement of the period of the system, which then compares this to the value of the spring constant determined by Hooke's law.
The materials used in this experiment include a C-clamp, a pendulum clamp, a 500-gram mass, a spring, a safety cage, a spark motion sensor, a smartphone camera, a ring stand, and a computer interface with the data acquisition software such as Spark. The experiment allowed us to find the spring constant using the mass spring method. The formula for the mass spring method is K equals 4 pi squared times the mass divided by the period squared. The period can be calculated by finding the difference between the two times when the weight goes to its maximum displacement. The spring constant can be calculated by using Hooke's law, F equals K divided by negative x, F being the force, x being the displacement, and K being the spring constant. The F is the force of gravity acting on the mass, or in this case, 9.8 times 0.5 kilograms. The displacement is the difference in position of the mass, as it moves up and down. The percent error is calculated by subtracting the theoretical value from the value that was obtained by doing the experiment, and dividing this difference by the theoretical value. When the absolute value of this answer is taken and multiplied by 100, the percent error is calculated. In this particular experiment, the theoretical value was obtained using Hooke's law, and the experimental value was based on the mass spring method.
All in all, the values of the spring constant calculated from simple harmonic motion using the period and the spring constant calculated using Hooke's law are very similar, with the former being 33.82 Newton meters and the latter being 35